Okay, let's start from question 1. So we'll be doing May 25 paper 4.2, and then we are given all these files as source files, so we'll be using them as we go along. And then we have to maintain an evidence document as well, so I'll only do a couple of questions for the evidence document, and then I'll assume you guys can do the rest. It's very simple. We just have to paste the code in the evidence file that's given to us. So we have to write the details here first in the header file, in the header area. So we have the candidate name, let's say I write my name, then the center number, maybe some school, and then the candidate number, maybe 0000. So this is the first step. Then in the second step, you have to save this evidence file in this format. You have to name it evidence dash followed by the center number and then followed by the candidate number. So I'll have to do that. So I'll go to file, save as, browse, and then wherever the current evidence is, I can just save it again. So this would be evidence, and my school was school name, or the candidate, the center name, and then my candidate number, that is structure 0, and then this is correct file now. And whenever you get the source files, you should always do one thing in advance, that is you should create a backup of these files. So as soon as you open the folder, copy it and just paste it there, then and there. Okay, so it will end up just creating a copy of it. So even if you end up editing the real files, you still have a backups to fall back to due to some reason in the exam. So backup is very important. This should be the first step. Now we'll start. So for question 1a, let's go ahead and read it. So they're saying you have to use class declarations can be used to declare a record, and if the language does not support arrays, then list can be used. This is specific to Python. Then the source files are given, that would be stack data, second stack, and hash data. A program reads data from a text file and stores it in a stack. The stack is stored as a 1D array of up to 20 elements. Okay, so I'll open the examples file so we can visualize it. We have a top of stack pointer that will store the index of the last element stored in the stack. Okay, so what does this all mean again? We'll just create a stack quickly. Something like this. Okay, so it will start from, so it will have some values, maybe math, CS, physics, and then we have the indices. We have 0, 1, 2. Okay, now the question says, this is the most important part, where the top of stack would point. So in our case, the top of stack is pointing to the index of the last element stored. So that means in this case, top will be pointing here. This is the last element that we stored. So in the other implementation of stack, we could have pointed the stack to the next available space. Okay, so then it changes the whole logic. So we are not doing that here because that is not what the question says. So stack is a global array of strings with all elements initialized to -1 in the string format. Then top is initialized to -1, write code to declare and initialize top of stack. Okay, so in Python, we don't have declarations as such. So what we have to do is, we first have to go into PyCharm, we'll create a directory. So we'll create on the main folder, new. We'll go to directory and then we'll name it. So I'm naming it 2025 major paper 4.2, and inside this I'll create a Python file and then we'll call it question 1, and now we can start writing the code. Secondly, how do we bring all the files that we have, the source files? So for that, we'll just go ahead into the folder, select all the files and we'll copy them. I'll just press Ctrl+C, and then I right click on the main folder, this folder that the question files are in, and then right click and then I click on paste, and here goes all the source file. Alright, so we can keep it open or we can close it, it's up to you. So let's start with the implementation. So stack is going to be, we have to declare the stack. So we have to write stack is equal to like this. It would be, so this is basically a declaration in stack, although we're initializing it to an empty array, but for now we'll just write it that this is a string array. And then they're saying that the top of stack should be set to -1. So top of stack should be set to -1. And then the question says that we have to copy and paste the code into 1A of our evidence document. Okay, so we'll just put this stuff. So I'll copy it. I'll go to my evidence file and I'll just get rid of this. I can paste it. And a good idea would be to right click and then paste to keep the source formatting. Okay, so it prints, it is pasted like this with the color coding and everything else. Otherwise it looks very weird and just like plain text. Now in the next step, what we can do is we can also initialize the array here. So the question says that all the elements should be initialized to -1 and then there are 20 elements. So in order to do that, we have to do the simple stuff. That is, we'll write string -1 for I or for any even dash in range of 20. So this means if I print the value of stack, it will print me -1s but 20 times. So we'll be creating an array with -1 that is replicated 20 times. So you can use any variable here, it's up to you, that's not an issue. And we can just go ahead.
When do we use the underscore or any variable?
It's up to you. You can use, you're asking when do we use them?
Yeah.
Because this is a simple for loop, right? For blank in range. So we have to put a placeholder here. So it could be anything. So you can just use simple J here. So I'll go ahead and I'll just paste this line in my code as well, like this. Okay, now we have part B now. So the function push will take a string parameter and attempt to store it on the stack. Okay, so we have to write a function. So we don't need to print this. And this should technically all be global. And okay, let's define the function here. So define push. It will take a new item here and then we have colon. So the question says that we have to store the value, and if the stack is full, we have to return -1. Okay, so how do we know the stack is full? Let's first see the maths on a small stack. Let's say we have a stack with the size of 5. So in this case, when the top is pointing to 0 to 4, that means there's supposed to be a value here. Let's say it's chemistry. And then we have 0, 1, 2, and this should be 3. And then if we want to add another value, first we'll increment the top by 1. This goes to index 4, and then maybe it could be some other subject, maybe environmental sciences. And then when we increment the top again, now it will point to 5. So we had the size of total 5 elements. So that means when top actually becomes equal to the size of the stack, the total number of values that should be in the stack, then that means that the stack is full. So these two values should not be allowed here. They are extra. Okay, so in this case, what would happen? So in case of when we have only, let's say, the total size of 5, so when top exceeds, or when top becomes equal to 5, or when top exceeds the value of 4, so in that case stack is full. So we can just use this as an example, and we can map this on the size of 20 values, I believe. Yes, the stack is of 20 values. So I'll go back, and it would be a good idea to also set a size to 20 like this. So first of all, I'll check if okay, first we have to global these as well, because we are accessing the global variable. If we don't make it global, then that could mean that we're using the local variable top of stack, and Python might not know that we are specifically referring to this variable that is global. So we have to global all of this. So global stack and then top of stack. Okay, then in the next part we are going to check if top of stack becomes equal to the size, which is 20. Now again, Since the size is 20, so the last available index would be 19. So when it exceeds that, so that means that the stack is full. Or we can just write if top becomes greater than 19 in this case, right? It's the same thing. Then we have to return -1. Alright, then the next part says that the function returns 1 if the parameter is successfully pushed onto the stack. Okay, so if that is not the case, else what we'll do is we'll actually put the value on the stack wherever the top is. So first you have to increment the top by 1. So the initial value of the top was set to -1, right? So obviously we cannot put a value at -1. So first you have to increment the value by 1. So it goes to 0 and then we place the value. So that is what I'll do. We'll say top plus equal to 1. Should be top of stack plus equal to 1. And then I go to the index that is referred to by stack and I'll place the new item there. And in the last step, I have to return the value of 1 because that is what the question says. Alright, so that's the idea here. Going back, then we will copy the code. So we have to copy this code. Okay, to avoid any confusion, you can always use the collapse function of the ID that you're using. Mostly it will be PyCharm. So you can just click on this arrow at the definition function and then you can just select this part and copy it. This would save time in the exam. So you go there and then this was part B. Get rid of this, right click, and then you have to paste to keep the formatting. This would be the first part, this first option. Okay, so this is keep source formatting and then it would be pasted like this. Then going to the next part, which is the pop function. So part C, we don't have to label these part C, part D because we're putting them in the evidence file. So the examiners would only be getting your evidence file, not the actual code. So if you write the whole correctly and then you don't paste it in the evidence file, you wouldn't get any credit. So then we have the function pop. Okay, so we have the function pop, and then the question says that we have to return the next item from the stack. The function returns -1 if the stack is empty. Alright, so we already know that the stack would be empty when the top of stack is pointing to -1 because that is what the initial value would be. So let's say if the top is pointing to -1, then we can safely assume that the stack is empty, there are no values there. So we can just go ahead and place the stack. So first of all, you have to global. Every time you have to global it. So if top of stack is equal to -1, then that means that the stack is empty. So we return string -1. Okay, otherwise they're saying return the next item stack. So in else statement, okay, what I'll do is, so again, I'll go back to my logic. So the current logic of the stack is like this. So the current logic is like this. So we have, let's say top is pointing to index 4, which is environmental management. So if we pop this value, then technically top has to go one step down. And before you actually subtract the value by 1, you have to save this value so you can return this. So this environmental management and whatever the value is, we'll actually store it somewhere and then we will reduce the value by 1. Otherwise we would end up losing the value because we have to return this. The question says that we have to, yes, we have to return the value. So this is the simple logic for this. So what we'll do is wherever the top is pointing right now, I'll just get that value and we can save it in temp. Temp is equal to stack and then we'll get the value which is pointed to by the top of stack. This would be the last value that was saved in the stack. And then we do, okay, if we just return temp here and then we do top of stack minus equal to 1. Now you can clearly see the error here. If I hover my mouse over it, it would say that, so we are trying to return, it's not, okay, this error, the code is unreachable, this code, okay, this error, the code is unreachable. Okay, so anything you write after the return statement would not be triggered because return means that we instantly terminate the function and return to main. So keeping that in mind, whatever you have to do before the main, before you return the value. So I'll write the main function here as well. And again, they've not asked us, but it's always a good idea to keep testing your code as you are typing it, so we have a good idea that it is working or not. All right, so we have the return temp and then return -1. So there was an issue with the indentation. Should be fixed now. Okay, now let's go ahead and just test our code so far. So we can add a value in the stack and we can remove a value from the stack. So let's use push function and let's put in some value, maybe test value, and then print the value of stack. So if I run it now, okay, perfect. We can see the test has been pushed onto index 0. Then if I push another value, should do the same thing again. So I'll just copy this and maybe let's call it test 2. And if I run it, it is working perfectly. And now let's try to pop a value and get it in a response variable, and let's print the value of response. And if I do it now, it should return me test. Okay, so this should return a value. Okay, it returns this test 2. Okay, so this is the value that we added afterwards. So whatever would be at the top of the stack would be returned. So everything is working fine so far, but we don't need to use it right now. The program will tell us what we have to do towards the end in order to test the code that we have written. All right, now in part C, so we just have to copy paste this over and over again. So I'm not going to do that anymore. You guys get the idea. Okay, in part D now, so this is an interesting part. Part D says there is a text file called stackdata.txt that stores the numbers and mathematical operators. Okay, before we even go, we should go and treat the stack data manually. And then we have the second stack file. We should also go through it. So there is a 3 plus 2 multiply 2, and then there are some values here, and similarly in another stack. All right. So each number and operator are on a new line in the text file. The mathematical operators are used here. Okay, so we have to write a procedure read data that will take a string file name as a parameter. It will open the file. Okay, so whenever we have to open and close files, we always have to use exception handling. So in the exam, you should also be in this habit that you should instantly annotate on the paper what functions or library routines or whatever you have to use so you don't forget it afterwards. So we have to use a try catch here. So in fact, before we proceed further, let's actually do this. And again, if this code confuses you, you can just collapse it so there's more space on the screen as well. So we're going to define read data that is going to take a string file name as a parameter. So file name, and then it will open the file and read each line of the file. All right, so we'll try. To open the file, and if that is not the case, so we'll show some sort of error. So we are opening the file in read mode. All right, then in the next part the question says we have to use the push function to insert each line of data onto the stack. All right, so looks simple so far, and then you have to output stack full. If any data cannot be stored on the stack because the stack is full, use exception handling. Okay, they've already told you that when opening and reading the file, and then it should work for unknown number of lines. So that means that if you are given any set of files, the code should work correctly on regardless of that. All right, so how do we do this question now? So whenever we open the file, we have to always close the file as well. And let's say if the file does not exist, so we should have some sort of except, and then we can just print file not found, something like this. All right. Okay, so we have to open the file and read in each line of the data. So let's open the file again. So we should be able to print all of this in in our console. So let's do that. For that, we have to use the for loop. So for line in the file, we just have to print every line and see if it works properly or not. So it does not work. Okay, we have to call the function. It should be read data, and then we'll call the file stack data.txt, if that is the right name. Okay, yes, we get all the lines one by one. Okay, but there are spaces in between which are the line breaks, so we need to get rid of them. And for this, we use the strip function. And then everything is fine. So we have successfully read the file into our program. Now they're saying that we have to use a push function to insert each line of data onto the stack. And we have to keep on doing this until the stack becomes full. Okay, so we have already written the push function. We just have to use that again. So let's do that. We have, okay, let's not print this. I'm going to comment this. We don't need to print this. And instead, let's call it maybe data, or let's call it item is equal to line.strip. And then once we have the item ready, we need to push the item. So push the item onto the stack. Now, if we look at the push function, it will return -1 if the stack is full, and otherwise it will return 1 if the stack is not full and the value is inserted properly. Alright, so I'll push the value and maybe I'll get the response from the push function. And if the response becomes equal to -1 at any point, then that means that the stack is full. So then they're saying that you have to output that the stack is full. So we should output stack is full, something like this. And that's it. That's all what we have to do. Otherwise, we'll keep on pushing the values for all the lines in the file. Right? So that's it. And if we run the program, let's see how it works. Okay, it doesn't print anything. And maybe after we close the file, let's try to print the state of the stack to see if all the values have been pushed. Yes, all of them have been pushed perfectly. So they were all -1s initially. Now they're not all -1s. They have the values that we had in the stack data file. So starting from 3 all the way till 10. So it is always nice to do a quick visual check. And yes, the ending value is 10 and the starting value is 3. Okay, then it is also working for unknown number of lines, because we didn't do any hard coding here. So we used a for loop for the whole file. We didn't write for I in range, let's say 10 lines, something like that. Okay, then we have part E. Part E is a bit tricky. So part E says the values stored in the stack are used to perform mathematical calculations. And then a total is initialized to the first value in the stack. The first value in the stack will always be a number. Okay, so the next value will be a mathematical operator. So the next value will be a mathematical operator, and the next value will be a number to apply the calculation to. Okay, what does this mean so far? So we'll go back to the file to get a better understanding of this, and we'll open the file. And we see it says 3 plus 2 plus 3 into 2. Okay, so this should be our total. Again, I have the backup saved so I can actually write some stuff here, but then we have to undo it. And then what we have to do is we have to use this operator and we have to add this value. So this total becomes 5 then. And then these value would be done. Then we have times 2, and then this becomes 10. And then we have the power exponent, and then should become 100, etc. So I'll undo this. This is what the question says. This is repeated until there are no values left in the stack. There will always be a number following a mathematical operator, so we're guaranteed of that. The total is initialized to the first value in the stack, which is 10. So the next two values are plus and 3, so the total becomes equal to 13. Then the next two values are minus and 2, so the total becomes 11. The final total is 11 and that is returned, so we have to write calculate code for that. Okay, so we'll also open the examiner report for this. So we look at the errors that were there, common errors, and how we should avoid them altogether. So this was not a well-attempted question. So candidates were able to check the multiplication symbol, but few candidates were able to write appropriate symbol for the function of raised to power of. And a lot of students attempted to use the exponent sign instead of converting it to the Pythonic form, which is double star. All right. So again, I think the question is pretty much clear. They have already given us an example, so we don't need to kind of visualize it on our own. So let's go ahead and try to solve the problem. So this would be the calculate function. All right, here we go. So we have defined calculate, and then calculate function is going to take each value from the stack, and then it will calculate and return the final total. Okay, so there's not supposed to be any parameters here. They've not told us to use any. So this is how it's going to be. Okay, so we already have the stack populated here. We have 3 plus 2, etc. So first of all, we have to get the total value, right? And the question specifically says that the first value will be the total value. So the first value would be the value that we have in the stack, this value, right? So let's say we have 3 here, then we have plus here, then we have, so we have plus here, then we have 2 here, so on and so forth. So we have minus here, etc. So this first value would be the total value, and we're assuming that this top is set to 0 right now, or we'll actually have to do that before we actually push the value. Or in fact, when we push the value, so it will automatically increment it by 1. And when we have pushed all these values on the stack, so the top would be somewhere around here. I'll get rid of this. So the top would be pointing to the first value on the stack, like the last value on the stack. So let's go ahead and pop that. So right now, this is where the top of stack is pointing. So this would be the first value would be the total. So let's call it maybe total. And we're going to get this value by using the pop function. Again, what will the pop function do? It will return you the last value that was stored on the stack. So this will get us the last total, or total stored on top of stack. So we don't have to write any comments here. I'm just doing it for explanation. Okay, then in the next part, by the way, you have to remember that anything that you write or read from a file, it is always in string, in the string data type. So if you want to confirm, you should just print the type of total. This is very helpful in the exam as well. And we're doing read data right now. So if I print this, I think I am in the wrong function right now. We should be in calculate. Yes. So let's comment this as well. And then let's run the calculate function. Okay, it says class string, right? So total is not an integer value. So we have to go ahead and we need to convert this into an integer value. So int total. Otherwise, it will start operating it as a string. Okay, so once we're done with that, now we'll start going through the whole stack, and we'll keep on doing this until the stack is empty. So when the stack is empty, it will return us a -1, right? Because when we are popping the values, eventually they become -1, as we said this here. The function returns -1 if the stack is empty. So we have to use some sort of a loop. So while maybe the current item is not equal to string -1, I believe. Yes, string -1. Like this. As long as that is not the case, we will keep on popping the values. Okay, now what is going to be in the item? So for now, we can just call it some random value. Maybe let's call it -99, just so that we can start this loop. Okay, now inside the loop, this is where all the main stuff is going to happen. So first of all, we need to get the next value now. The question says that the first value would be the total, the second value would be operator, and then the third value would also be an operand. So now this value that we're going to pop would be the actual operator, because we have already popped the value once, which gave us the first total. So right now the top of stack is pointing here on this plus. That is what we're going to do. So I'm going to write let's say operator is equal to pop. This will give us the current operator on top of stack, right? Okay, now we check the pop function. So it will return us some value or it will return us -1. Okay, before we actually do this, we should have some sort of a mechanism here that if the stack is actually empty or not. So in fact, we'll check it towards the end. Okay, I think this should be fine. So this is item. We're checking if it is equal to -1. Should be item. We're going to pop it here. All right. Then we are going to get the operator here. We're assuming we're getting an operator, so we can just apply. So let's write operator here, and then initially we can also just call it. Okay, so here we'll write the conditions. So if operator is equal to plus, so if we get the plus sign, so what we have to do is we then have to get the next value that would also be popped. So we had the first value that we popped, which got us the total. Then we got the second pop, and then that gave us the operator. And then we have to pop the value again to get this current value here. So if the operator is equal to plus, then we are simply going to pop the value that currently we have on stack. So this value will be popped again, and then the top will be pointing on this value. So yes, total plus equal to pop, or we should save it actually somewhere, or we can call it like this. Okay, then LF operator is equal to minus, then total minus equal to the value that we would have popped, then LF operator is equal to multiplication, so we'll multiply it. How many operators are there? We have okay, we have till the raised to power of. Okay, then we have LF operator is equal to division, then we divide it, and then we have LF operator is equal to the raised to power of, so we need to replace it with the Python version of it. That would be total is equal to total raised to power the value of pop, like this. Okay, so yeah, so when you're popping the value again, it would be in string format, so I need to convert these all into integers, or we can just do it here once. So let's call it operand, and operand would be equal to int, the value that we popped again, like this, and then we can replace all of this with the operand, and then this is operand, all of them become operand, right? So then at the end we go all the way up and we check is the value equal to -1 yet. If it is not, then we again pop the operator, then we pop the operand, and this keeps on happening over and over again. And back to the question, it says that we have to keep on doing this until the stack becomes full, and as we know that the stack will become full when we keep on, when it returns -1 when pushing the values. So since we are popping the values, so it should return -1 when the stack becomes empty, not full, right? So eventually it will return -1, and then that would be it. And then at the end we have to, I believe, return the value of total. Yes, so we have to write return outside the loop, so it should be return total, like this. All right, and then they're saying you have to paste this. Okay, then in the file part of the code, we have to write a program code to extend the main program to take a file name as input from the user. Okay, so we go into the main program. Now this is where we're going to actually test the program, take a file name as input from the user. So fname is equal to input, enter file name, then call read data with the input file name. So we'll use read data, and we use file name, and then call the calculate function, Okay, so again, read data was supposed to return some value. Okay, it's not supposed to return a value. All right. And then we have, okay, so going back, so we have the read data here, and then we have to use the calculate function, and then we have to output the total. So we'll cache the total here because it's returning a value, and then we'll print, let's say, total of stack maybe, and then this will be followed by total variable. Okay, and then we have to paste this and then test your program. So write the program. Okay, then test your program twice with the file names stackdata.txt. Okay, let's do that first of all. So we have written all of them. Hopefully they would be working. I believe calculate might have an issue. So it should be stackdata.txt. Okay, the total of stack is 131. All right, so we are getting something. And again, a good idea would be to manually verify this. So, and then the second part says that you need to take a screenshot of the outputs. Okay, so this is not part of the output, so I need to comment this out. I believe this was in read data. So where is print stack? Let me see. Yes, this sign, so I'll just get it out. So read data once, I'll rerun it, and then stack data.txt. Okay, so I have to just go ahead and I can use a snipping tool or any other screenshot way that you know of. You just need to take the screenshot of this part, okay, not the whole thing. And you'll just go ahead and you'll paste it in your evidence file. In fact, we should do that quickly. So we'll go to our evidence file and we'll go and paste it in the required question. Also, please remember that this code must not be pasted. The screenshot has to be like, it should be a little screenshot. You cannot just paste it. Okay, so this shouldn't be text. This is specifically mentioned in the examiner report as well, and when we're marking the exam, it is a very it's an instruction that is repeated often. All right, then in the next part we have to use second data.txt. So we go back, and this time I'm going to repeat the code, and I'll write second stack.txt. So it returns an output of 320. So again, I'll take a screenshot of this, and then we'll go and paste it here like this, right? Okay, and then okay, that's it. That's the whole question. So question one, and